everyone, I'm Ashley Davis, developer of DataForge Notebook and author of Data Wrangling with JavaScript. This video is for those of you interested in using DataForge Notebook to help with your quantitative trading needs. How does DataForge Notebook help you? You can use it to prototype code for your trading strategy. You can use it to backtest your trading strategies and analyze the results. You can optimize your strategies and do Monte Carlo testing. In fact, you aren't limited at all. If you can imagine it and you can code it, then you can achieve it with DataForge Notebook. Some of the new example notebooks that I've been adding to DataForge Notebook recently demonstrate its capabilities in relation to quantitative trading, and that's what I want to show you in this video today. These examples help you understand how DataForge Notebook works and what you can do with it. All the notebooks that you will see in this video bundled with DataForge Notebook and come included with it. So when you install DataForge Notebook, get all these notebooks as well as many more. This first example notebook that I have open shows how to use DataForge Notebook to backtest a simple mean reversion trading system. All of these notebooks in this video, they make use of the Grademark API. First, we start by loading and preparing our data. We could load our data from any source that we like, for example, a REST API or a database, but for simplicity in these examples, we are loading our data from a CSV data file. After that, you can see that we have previewed the data in a tabular format. We do this just to make sure that the data has been loaded and parsed correctly. There'd be no point moving forward from here if the data was corrupt or if we had a bug in our code. Next, we plot our input data series. We do this to get a better feel for our data and again just to double check that our data is okay. Any quantitative system relies on having some indicators that generate trading signals. So in this next bit of code, we compute the simplest possible indicator that would work for this trading strategy. We are computing a simple moving average and then we preview and plot our data to make sure it looks as we expect. Next, we define our trading strategy. This code specifies our simple mean reversion trading system in a format that can be backtested by the Grademark API. We have rules here for defining when to enter and exit positions. We also have a stop loss rule that can exit positions quickly to prevent further loss. After defining our strategy, we can simulate trading by running a backtest and then plot a chart to visualize the trading results. After backtesting, we'll want to analyze our trading strategy. You can use whatever statistical methods you want to analyze the results, but in this example, I'm simply calling the Grademark analyze function that outputs a bunch of useful performance metrics. Also common is to render an equity curve that shows the growth of our trading system over time. And another useful chart shows drawdown. This gives us an understanding of how much time our trading strategy is underwater. I have to stress at this point that you can generate whatever charts you want from whatever data you want. This isn't hard-coded just for these two types of charts. You have a lot of power at your fingertips here for creating different kinds of charts from whatever data you can load or compute. Now this example, this is just the first example. It's only really just scratching the surface of what we can do with DataForge Notebook. Let's have a look at some other examples. You can see here all the example notebooks that are included with DataForge Notebook. Now let's have a look at an example of a Monte Carlo simulation. This example notebook shows Monte Carlo simulation, which is a statistical technique where we create and analyze random samples from a larger population. We can look at the average performance across the samples to build a more statistically significant understanding of the performance of our trading strategy. At the start of the notebook, we are preparing our data as before. We then backtest to generate a population of trades. Next, we call the Grademark Monte Carlo function to generate 1,000 samples. Each sample contains 50 random trades from the whole population. Now we can do whatever analysis we want on our selection of random samples. Here I'm computing some metrics and rendering some charts to show the spectrum of profits and drawdowns that are produced by the range of random samples. This next example notebook shows how we can optimize a trading strategy to find the best parameter values. As before, it starts with preparing our data and defining our trading strategy. Then we call the Grademark optimization function. We need to tell it which parameters and which range of values for each parameter search for optimal values. In this example, we are optimizing the period parameter to the simple moving average indicator. This optimization process allows us to find the best value for the indicator. You can see at the end of the notebook here, we are plotting a chart that shows the relationship of the moving average period parameter to the profit produced. From this I can see that a value of 28 or nearby produces a high level of profit that is relatively stable across nearby parameter values. Here's another example notebook. This shows us how to chart the value of a trailing stop loss over the duration of a particular trade. You can use DataForge Notebook to drill down into any of your data and visualize it. This can really help you when you want to build an intimate knowledge of how your trading strategy responds under differing market conditions. Finally, let's look at the most advanced example notebook that's included with DataForge Notebook. This notebook contains an example of walk-forward optimization. This process allows us to simulate a strategy that is progressively and incrementally optimized over time. We do a bit of optimization, followed by a bit of backtesting, followed by a bit of optimization, followed by a bit of backtesting. In this example, we are optimizing on 90 days of history, and then we backtest for 30 days and repeat. This process simulates what would happen if we re-optimize our strategy every month based on 3 months of recent historical data. We can thus build a list of trades from which we can do further analysis. That's it for today. We've looked at some example notebooks relating to quantitative trading, plenty of other examples there as well that are included with DataForge Notebook, and more examples are added with every release. And just remember that these are just specific examples. DataForge Notebook is actually a general purpose coding platform for data science and visualization. You can use it however you want, in whatever way you want. And you can see from these examples, I've shown there are many possibilities. These techniques for quantitative trading can be pieced together in many different ways. For example, in my own strategy development process, I often do walk-forward optimization to generate trades, and then I do Monte Carlo simulation on the result. To stay updated about what I'm doing, please follow me on Twitter or take a look at my blog or my YouTube channel. If you don't have DataForge Notebook yet, please head over to dataforgenotebook.com and register your interest. Thank you for listening. Bye-bye.